Welcome back. Here we are going to start lecture number 2. That would be about another representation, which is hexadecimal number system. In our first lesson we discussed about the first number system, that was binary representation system, and now we are going to discuss about hexadecimal number system. So before starting the hexadecimal number system, I'll give you some of the important points regarding this. Students, you must be know about it that hexadecimal number system basically consisting on base 16. This is a point that you need to understand. It's base 16 number. All right, and the next the case is that alright, still let me correct it. Alright, so the next thing is this its range is from 0 to 9. Alright, and the rest of all digits like 10, like 11, and then 12, and then 13, and 14, and 15, all these digits will be represented by letters. That A will be represented by A, 10 will be represented by A, 11 will be represented by B, 12 will be represented by C, 13 will be represented by D, and 14 will be represented by E, and 15 will be represented by F. Alright, so this is the method you need to follow up, or you can say that these are the key points that you need to remember for base 16 number system. Alright, so the next thing what we are going to do in our chapter number 1 in the topic of binary representation number system, we also discuss about it that we can be having a 4 number of bits, we can be having a 8 number of bits, and 12 number of bits, and up to so on. So here I'm going to discuss the first case, which is binary to hexa. Alright, binary to hexadecimal number system. And in this case, let's suppose we have 8-bit number system. Alright, we have 8-bit number system. Let's suppose we have 0, we have 1, we have 1, 1, we have another 1, again we have 1, we have 1, and 0, and 1. So these are 8 number bits are given. If the number is given in this format, so what the thing you have to do, you will make a group of 4 bits, and it will be starting from its right side. Again you are going to make another group of 4 bits, and you will go for the same procedure from right to left. Sorry if I said the left side, it is from right to left. So the next thing is this, you will start writing the place values of all these numbers. In our first lesson we discussed about the place values as well. So we have a first group 4 bits, so place value would be 1, another will be 2, and the next will be 4, and the same like this, next will be 8. Another group you will start writing place values from starting the value 1, 2, 4, and the same like this 8. Alright, students, as in our first lesson we discussed about 0 and 1. These are 2 bits, and 0 always indicate that your bit is off. Alright, and 1 always indicate that your bits are on. And when you're working with the number system, you must keep it in your mind that will pick up all those bits which are on. So here you can see these bits are on 4, 2, and 1. The same thing for the another group 1, 4, and 2. So now you are just going to add up all these bits, like the first one was 4, and plus 2, and plus 1. Alright, another was 8 plus 4, and 4 plus 2, and plus 1. Alright, so this was another thing. So when you are going to 8 alright, it's just because of this I couldn't see that what is the actual number. So just let me correct it. Okay, it was 8 plus 4 and plus 1. So just forget this number system. Alright, just forget these numbers. Here is 1. Now you are supposed to calculate the values. 4 plus 2 plus 1, which is equals to 7. 8 plus 4 plus 1, which is equals to 13. 8 plus 4, which equals 12, and adding a 1, which is equals to 13. So here you can see the 13 is represented by D. So the correct answer will be 7D. This is the way how will you convert a binary number into a denary number system, or sorry, the hexadecimal number system. Alright, so come over to your exam book, and let's discuss another examples as well. The book is basically specified, or you can say suggested by the Cambridge. I must suggest to all of you, either you are part of IGCSE or either you are part of a GCSE, you must go from this book and just prepare all the stuff from this book, because you just need to prepare the content, and on that content base you have to prepare the paper, and you just have to attempt the paper as well. Now here is the first scenario, as we have discussed about it, that we are going to convert a binary number from binary to hexa, and then from later we will discuss about later hexa to binary. So here you can see the 12 bits are given, and if the 12 bits are given, the first group of 4 bits 0001, another is 1110. So we write down separately 1110 and 1011 and 1011. Now we will start writing the place values. Here you can say the just a 1 bit is on, so it will be same like this. 1 will be right over there. Another is 011, so we will write on the place value, that would be 1, 2, and the rest is 4, and the next is 8. Okay, so 8 plus 4, which is equal to 12, and 13, 14, and it would be represented by E. And the next is 1, 2, 4, and the next is 8. So 9, 10, and 11. So 11 is represented by B. So the correct answer will be BE1. This is the way how can you convert if a binary number is given to convert into hexadecimal number system. Alright, so another number is given, which is about 4 and 8 and 12 and 14. The students, as I told you, you will always make a group of 4 bits. So the first group of 4 bits 1101, the next is 1111, and the next is 1000. Now you will be think about it, what about these 2 bits? These are not making a group of 4 bits. So in this case we are supposed to make a group of 4 bits to add 2 additional zeros on its left side. Always remember, when it is a time to complete a group of 8 bits, either it is an 8, either it is in a 4, either it is in a 16, or the 13, 32, you are always supposed to add additional zeros on its left side. Remember it, please, and note it. Now the next the same procedure we will revise. 1101, it is 1, 2, 4, 8, and 13 will be represented by D. This is 1, 2, 4, 8, and it is 15, that would be represented by F. It is 1, so it will be written like as it 1, and the next is 1, 2. So we will write over there 2, and 2 will be placed over there. So the correct answer is 21FP. Here is another example. If a binary number is given and the bits are missing, so how will you complete it, and how will you convert into hexadecimal number system? So we are supposed to convert the case 2. Case 2, which is if hexa number is given, how will you convert this hexa into binary.